Hi grade 12s, we're moving on to our last topic in grade 12 trig. We do still have three-dimensional trig to do, which is very similar to 2D trig, but in classic trig section we've got one last topic, and that is trig equations. So this is topic 6. There's going to be a couple of subheadings on topic 6 and as they get more difficult, but we're beginning in this video with topic 6.1, which is just your basic grade 11 examples. Right, so let's have a look at our first example, which is literally the basic sine equation, the basic cos equation, and the basic tan equation. So let's look at example 1. Solve for theta if sine of theta is equal to a half. Now, you will remember from grade 11, hopefully, that basically all trig equations come down to the fact that there's 4 quadrants, and that each trig ratio has 2 quadrants where they're positive in. So sine is positive in quadrant 1 and in quadrant 2. Now, fortunately, in quadrant 1, your angle is just theta. But in quadrant 2, it's 180 minus theta, because that's the angle of theta, and so that's 180 minus theta. So that'll help us a bit in looking at how we find the solution to this first equation. So sine theta is equal to a half. I don't know if you remember that your first answer for sine is just equal to shift sine. So if you go into your calculator, so let me just write myself a note here. If you push shift and then you push sine, it basically comes up with the inverse function of sine, which looks like that, and you put that onto your calculator. And you shift sine a half, and you should get an answer of 30 degrees. Okay, always just make sure that your calculator is in degrees, so it should have the little d at the top of the screen. So shift sine of a half should give you 30. Now don't forget that that means that an angle of 30 in this first quadrant, an angle of 30 degrees, will give you a sine ratio of a half. But don't forget that 360 degrees later, you'd be in exactly the same position. So the general solution is plus k 360 degrees, and you have to explain that k is an element of integers. So your first solution for sine is always just shift sine. Your second solution for sine is the fact that you could be working in the second quadrant. So theta could be 180 degrees minus 30 plus this k 360, because again, that position will occur 360 degrees later again. Now 180 degrees minus 30 is just 150. So this just then simplifies to 150 degrees plus k 360. So this is how we find a trig solution to a sine equation. So the first answer is you just do shift sine of the ratio. And our second solution is we do 180 degrees minus that shift sine of the ratio. So I'm hoping that rings some bells from grade 11. I promise you we're going to practice so many trig equations that you will remember them quite quickly. Okay, let's look at cos. Cos is definitely easier than sine in a way, because cos's solutions are in quadrant 1 and quadrant 4. So all stations to Cape Town. So cos is positive in 1 and positive in quadrant 4, which means any solution for a cos equation, if it's a positive ratio, will just be theta or negative theta. So actually sine equations are very, very nice, because I literally just say theta equals, and I'm just going to write myself a note here, it's basically just plus or minus the shift cos, as in the inverse function of the ratio. So literally you just pick up your calculator, you go shift cos, you put in 0.75 and you get out an angle. And this is just the plus or the minus version, in this case of 41,41 degrees. Again, all of these angles will occur exactly 360 degrees later. So plus k 360 degrees, k is an element of integers. So I like cos because while it has 2 solutions, they're so directly related, you can actually do that in one line, which is quite nice. So there we go. Our cos solutions are always shift cos of the ratio, but it's the plus and minus version of that. Okay, so last one to go is our tan equations. Now tans are definitely my favorite. The reason why they're my favorite is tan is positive in quadrant 1 and quadrant 3. Now that makes them quite unique in that the 2 solutions have a sort of symmetry, because if you find a solution to a tan equation, exactly 180 degrees later there's another solution. And so this angle here is actually 180 degrees plus theta, or theta plus 180. And so there's a symmetry between them. So for tan, you don't actually have to find both of the solutions in the first 360, because if you add 180 degrees to the first solution, you automatically generate that second solution. So in this case, I'm just going to, and I write myself a note here, I shift tan, so tan to the minus 1 of 3, and I don't actually, as I've said, have to find the second solution. So I simply find that, which is 71,57 degrees, and then you just write plus k 180. K is an element of integers. Because actually, what is the second solution if I just add 180? So I would get, what, 251,57. That would be the second. So this automatically generates your second solution. Automatically generates the second solution within that first 360 degrees. So tan, definitely my favorite, because it's literally just shift tan of the ratio and then plus k 180. Okay, so that was just a brief, quick introduction to sine, cos, and tan, and hopefully that's entirely what you remember from grade 11. So let's make it a little bit more interesting in example 2. What happens if you start messing with what you're taking the sine of? So for example, sine of 2 theta. Well, sine is, I'm going to shift sine, except now it's not theta that's equal to this, it's 2 theta. So what I'm going to do on the side here, I'm just going to write down what my calculator would say. I'm going to shift sine, which means my calculator would be inverse of sine of 3 over 2. And you should get 60 degrees. Now, the moment you tell me that 2 theta equals 60, you should always say plus k 360. K is an element of integers. So the moment you write down what the solution is, you should write down its kind of entourage, the plus k 360 bit. Now, or, how do we work out the second solution for sine? We do 180 minus. So, or 2 theta equals 180 degrees minus 60 plus k 360. K is an element of integers. Now, I always set up both of those solutions first before I go and solve, and I'll show you why. I now need to divide by 2, so you divide 60 by 2 and you get 30, and you have to divide 360 by 2 and you get 180 degrees, and I'll explain that in a second. Now, what lots of people do is, because they've now found theta is 30, people start using that 30 over here. So just be very careful. I always set up my solutions and then go and solve so that I never make that mistake. Now, why is it plus k 180? Well, algebraically it's k 180 because I divided everything by 2. Mathematically it's 180 because the period of a graph of sine of 2 theta, everything's happening twice as fast if that was a graph. And so the period of that sine graph is now 180. So every angle actually repeats itself every 180 degrees. Okay, now this last solution, I kind of get a bit lazy, so I go 180 minus 60 is 120, and divide by 2 is 60. And this is again plus k 180. K is an element of integers. So I got a bit lazy there, and there's nothing wrong with being a bit lazy. You also don't actually have to show that subtraction. You're welcome to just do 180 minus 60 in your head and write 2 theta equals 120. Okay, so let's do an example of where we have a negative ratio and we have a translation if you're thinking this is a graph. So it's a cos, which is nice because it's one of the easier versions. So basically I get theta minus 10 equals, and I'm just going to shift cos, which is cos minus 1 of negative a half. Now you keep the negative in there, so you don't ignore it. You shift cos of negative a half, and it should give you 120 degrees on your calculator. So it's 120 degrees, and you write plus k 360. Now why is it 120? And why is that in the second quadrant? Well, because this was a negative ratio, and cos is negative in the second quadrant. Now, or, and again, always set up the second option before you solve for theta, otherwise we tend to make mistakes. Now, what was cos's kind of trick? Cos's answers are always the positive version of the angle or the negative version of the angle. So negative 120 plus k 360. K is an element of integers. Now obviously I have to go and solve both of those. Now let me just explain why this makes logical sense. 120 degrees would be in quadrant 2. and that's when cos is negative, so that makes sense. Negative 120 will be past negative 90 and into quadrant 3, and that's the other place where cos is negative. So both of these answers actually do make sense. Now I would add 10 to both sides, so this is just 1 plus 10. Now notice, so it's 130. I don't add 10 to the K360 because algebraically K360 plus 10, they're not like terms, but also because the period of cos theta minus 10 is still 360. The period didn't change, and so the angle doesn't repeat any differently to 360 degrees. Now if I add 10 to this side, I get minus 110, and again plus K360. K is an element of integers. Okay, then last one for this one. First of all, this equation was just slightly different because your first port of call is to isolate your trig ratio. So tan of theta equals, that's not my best theta, let's try again. Tan of theta equals, and I'm minus 1 on both sides and divided by 3. So I'm just going to write myself a note here. This was quite a classic grade 11 example. Always isolate your trig ratio first. Now again, this is a negative ratio, but your method doesn't change. I'm literally just going to shift tan, so I'm going to get tan to the minus 1 of minus 1/3. And wonderfully, it's a tan function, and so I don't have to worry about a second solution. The second solution automatically generates itself because you write plus K180. So I got negative 18,43 degrees, but I'm going to write plus K180. K is an element of integers. Now where is that as an angle? Let me just check that this is right. Well, negative 18 would be there, and that's the fourth quadrant, and tan is negative there. If I added 180 like the answer suggests, I get into quadrant 2, and that's the other place where tan is negative. Now please just be really careful. If you're marking from a textbook memo or you're marking from an exam memo, often this question, for example, might say theta equals, and it might give you an answer of 161,57 plus K180. K is an element of integers. And then you start to think that you're incorrect because you're like, how did they get that? Just be very careful. There are many ways to write exactly the same answer. These angles are connected. If I take negative 18,43 and I add 180, you get 161,57. So if you don't get an answer that the memo gets, just check. If you add the 180 or you minus the 180, do you get to that angle? In which case it's actually just a different way to express the same thing. Okay, so last example of recapping grade 11 is the other thing we did in grade 11, which was the idea of when the equation itself is a little bit complicated. And so example 3 is all about factorizing, which was quite a common thing that we did in grade 11 trig equations. So solve for theta. Now in this case they're actually giving me a specific domain as well, so I'm not going to only give a general solution, I'm then going to specify which solutions fall in that domain. So the first kind of step is to isolate the trig ratio, and here you couldn't because there were lots of trig ratios. So if I factorize out, this is actually like a quadratic equation, and I get either the fact that cos theta must be 0, or the fact that tan theta minus 1 must be 0, which means that tan theta must be 1. Now tan is a nice one to answer, so let's do that guy first. So I shift tan of 1, and I got 45. So it's 45 degrees plus K180. K is an element of integers. Sorry, ran out of space. Now, of course, I need to go and figure out which one of those solutions lie in that domain, but I'll get there in a moment. Cos theta equals 0. Whenever you're doing cos equaling 0 or 1, the answers are generally kind of related. So if you do shift cos of 0, you'll get the fact that the answer is 90. So you get plus or minus 90, because that's how we answer cos equations. Plus minus 90 plus K360. K is an element of integers. Now, sometimes the solution won't be written like that, and it doesn't mean that the solution is wrong. There are different ways to write this. Plus 90 is there. That's plus 90 degrees. Minus 90 is there. Those two answers are connected by 180 degrees. So if you wanted to, you could write theta is 90 degrees plus K180. k is the element of integers, because then 90 minus 180 would get you to the other solution of minus 90. Now that only happens when you get sine equals 0 or cos equals 0. Then there's a connection between the answers because they're on the axes, so they happen to be connected. So always look out for sine and cos equals 0 or 1. There's always something interesting about their solutions. So don't think again that the memo gives a different answer to you. It's just a different way to write the same thing. Now this particular question said from minus 360 to 360. So if I look at this version of our answer, well, first of all, would 90 degrees be in that domain? And yes, it would be. If I add 180, I get 270, which is still in that domain. If I add another 180, I get more than 360. So if I go back and I subtract 180 from 90, I get minus 90, which I expected because it was one of the solutions. If I minus another 180, I get minus 270, which is still in the domain. But now if I keep on subtracting 180, I will get out of that domain. And now if I check my 45, 45 is in that domain. If I add 180, I get 225. If I add another 180, I get bigger than 360. So if I go back to 45 and I minus 180, you get minus 135, which is again acceptable. And if I minus another 180, I get minus 315, which is again an acceptable solution. So that's the whole long list of solutions that fit this particular domain given. Okay, let's try one last one in factorizing. And the last one in factorizing looks decidedly like a trinomial. So lots of people, when it comes to trinomials in trig and they don't like them, is they go do the k method or the a method, where you go and substitute in tan for a, and you factorize the whole thing using a, and then basically solving an equation by substitution. So if I factorize this with substitution, I get minus 3 plus 1. If you factorize this using the trig ratios, because you didn't use substitution, you would just get tan theta instead of the a, really. And so we land up in two solutions for tan. So we get tan theta equals negative 1, or tan theta equals 3. And tan is such a lovely equation to work with because I just do shift tan and I don't have to worry about the second solution. So if I do shift tan of negative 1, I get negative 45 degrees plus k 180. K is an element of integers. And if I do shift tan of 3, I get theta is equal to 71,57 plus k 180. K is an element of integers. Now again, sorry, I ran out of space there. Here they gave me a domain again, so from 0 to 360. So let's start. Well, negative 45 is therefore not acceptable. But if I take negative 45 and I add 180, I get to 135 degrees, which is acceptable. Now if I take 135 and I add another 180, because I'm allowed to add and subtract as many 180s as I want, I get 315, which is acceptable. Now there's no need for me to subtract 180s because it said from 0 upwards. So then if I continue with my 71,57, 71,57 is acceptable. And then if I add 180, I'll get an acceptable answer of 251,57 degrees. And then if I add more 180s, I get bigger than 360. So there's 4 answers that are acceptable in this particular domain. Now that's pretty much a basic rundown of grade 11. That's a very fast rundown because we spent a lot of time in grade 11. And so if you're feeling a little bit like can't really remember this, we're going to do a lot more equations which reinforce these basics. So most importantly, you need to isolate the trig ratio. Sometimes that involves factorizing. And then you've got to know what is the method for a sine equation, what is the method for cos, what is the method for tan. So don't forget the method for sine. If I just quickly summarize them, the method for sine equations is you basically do shift sine of your ratio, even though if it's positive or negative you do the same thing, or you do 180 degrees minus what you get there. Don't forget to rather set these equations up before you start solving because it avoids issues. Okay, the cos one, I love cos because cos is just plus or minus shift cos of the ratio, and tan is even better because tan is just shift tan. You just have to remember with tan that you have to add K180 and not K360, whereas the other two you're adding a K360. So that's pretty much a brief kind of synopsis of what we should know from this video. Then now we can move on to the far more exciting stuff, which involves grade 12 as well.